So now we are going to discuss about multiplexing. So what is multiplexing and why it is required? So usually when we talk with regard to multiplexing, uh, let us understand that concept about multiplexing with this simple example that is given in the figure. You can see multiple hosts that are sending the data. Okay, I would be referring them as sender, and there is one transmission medium that is there between the sender part and the receiver part, and there are multiple receivers who are ready to receive the data. So this is a specific technique that allows efficient utilization of the bandwidth. Okay, so it says what technique which allows multiple signals over the same data link. So though multiple signals are getting generated at the sender side, but those signals are becoming complex, and they are getting transmitted over the transmission medium, and with that particular transmission medium it is being received at the receiver side. So it says what, in simple words, sharing of medium between multiple signals. So these are the multiple signals that are getting clubbed together, and they are getting transmitted over the transmission medium and then are being received by the receiver side. Now the two element that are present is multiplexer and demultiplexer. So when I talk with regard to multiplexer, it says device that combines multiple signals into one. So though multiple devices are connected to the multiplexer, what is happening? Multiple devices initiate the data communication. So initiate the sending of the data. And when I talk with regard to demultiplexer, it says device that separates the multiplexed signals. So though this is a transmission medium that is, incorporating this individual signals that is being generated by the various sources, what we do is that on the transmission medium, those signals are clubbed together by multiplexer and they are sent as a single signal, single complex signal. So when it is received at the receiver side, what happens? The demultiplexer does the exactly opposite process of that of multiplexer. It takes the complex signal and then it bifurcates it into individual signals. So at the receiver side, what happens? These signals are received at an individual nodes. So when I talk with regard to multiplexing, the two important terms that we are going to keep in mind is multiplexer that would be there on the source or the sender side, and demultiplexer that would be there at the receiver side. Next we have types. So what are the types that are present is space division multiplexing, frequency division multiplexing, time division multiplexing, and code division multiplexing. So these are the major types of multiplexing techniques that we are going to study in this particular concept about multiplexing. Let us go to each multiplexing type one by one. So when I talk with regard to space division multiplexing, what is it? It talks with regard to spatial dimension that is used for multiplexing. Now, what do I mean by spatial dimension? Means what? Each channel is being given a separate space. So if I say K1, K1 is given a separate space, K2 is given a separate space, and so on. And this space has what? This space is defined via three parameters, that is code, time, and frequency. So within this space, you have these three elements that are there on which multiplexing can be happened. So in short, I can even say that SDM, space division multiplexing, cannot stand by its own. You need to have some other multiplexing techniques that should be combined together with the SDM. It says then what? Data streams are transmitted over non-overlapping transmission channel. Why the term non-overlapping? Because, and the next point it says that the space between the interference ranges is called as the guard space. The concept about non-overlapping, why it is being referred to as non-overlapping transmission channel? Because as we can see here, the different space ranges that are defined. So when you talk with regard to spatial dimension, you are having different spatial dimension for different channel. Okay. Next is what? Because they are distinct for the individual channels that are going to transmit the data or that are going to initiate any kind of transmission, uh, to avoid interferences between the individual channels, okay, and their data transmission, you have, a space called as guard space. So guard space does what? Basically tries to avoid data mixing. So when you have station K1, okay, that has space S1, station K2 or channel K2 that has space S2, channel K3 that has space S3, okay. So this spaces would be defined in such a way that there is what? There is no overlapping, there is no interferences that are being caused when two channels are going to transmit their data. So in order to avoid the interferences, you have what? Your card space that are there in picture. So interference range, within a third even larger radius, the sender may interfere with other transmission by adding to the background noise. A receiver will not be able to detect the signals, but the signals may disturb other signals. Now, what exactly this interference range is talking about is something related to the guard space. So when we talk with regard to spatial dimension, and when we say that the spaces are distinct, what we are trying to contemplate with regard to this distinct spaces is that when you have different spatial dimensions that are defined, even if there is some kind of interference because of the guard spaces that are there in existence, okay, even the noise, if it gets introduced, the receiver won't be able to understand that specific noise. So the receiver will not be able to detect that signal that is having noise, okay. So that is what is enabling to avoid the mixing of signal. This particular diagram, you can see it in zoom, wherein we have channels that are defined from K1 to K6. You have different spaces that are defined. Here we have written S1, S2 and S3, that is corresponding to K1, K2, K3. And this CTF is nothing but your code, time and frequency. So that is what I said, it is not going to stand alone, but it would be having what? Some other multiplexing technique that would be there with it, that would be there in existence with space division multiplexing. So you have these three individual spaces that are defined for these three channels. Now imagine I have to have a different space for 4, 5, 6. So this is one of the drawback of, space division multiplexing. When you have more channels that are ready for transmission, then in that particular scenario, how the spaces are going to be assigned? That is, large number of spaces needs to be there available with a specific guard spaces interference ranges that can be assigned so that there is no overlapping of signal happens. So that is what your space division multiplexing is talking about. Next is frequency division multiplexing. Now, as you have seen space division multiplexing, now we are talking with regard to frequency division multiplexing. Now, what is frequency and what is frequency division? So basically, when I talk with regard to frequency and frequency division, here you can see the channels are utilizing the transmission medium, or they are going to transmit based on a frequency that is allocated to them. So channel C1 would be having, say for example, frequency F0 to F1. Channel C2 would be having F3 to F4, F6 to F7 and so on. So within that particular frequency range only, the channels are entitled to transmit their data. Okay. So when I say that channels are going to utilize the frequency, means what? They would be taking into consideration that frequency range only when they want to do what? When they are going to transmit their data, okay, and the receivers are going to receive it. Now, important when we talk with regard to frequency division multiplexing, it is what? That though the frequency ranges are defined, still you can see what? Between each individual channel that is depicted in this particular figure, there is some space, okay. So again, the concept about guard spaces between the different frequencies are introduced. Guard spaces are mostly introduced in every multiplexing technique. Why? To avoid overlapping of the transmitted data, so that that particular transmitted data should not get impacted, okay, by the means of overlapping. It should not get destroyed, it should not get corrupted, nor the noise should be able to affect that particular data. So what it says, in frequency division, the frequency dimension spectrum is split into bands of smaller frequency. So you can see that this particular frequency, this particular axis is depicting frequency, and that is getting divided into what? Specific bands. FDM is used because of the fact that a number of frequency band can work simultaneously without any time constraint. Definitely. If I know at this particular frequency I'm going to receive the data, I can do what? I can receive, I can, tune into that particular frequency and receive the data. Example that is being given is that of FM radio. Who do not know how to, use radio. So if you want to listen to 91.7 FM, you are, constantly receiving data. The sender is constantly sending the data. You want to receive the data, you tune into that particular frequency and you would be receiving the data. Now, with regard to guard spaces and with regard to the FM radio example, I will say that when you say that 91.7 FM is the exact frequency where I will be receiving the appropriate data, does that mean I won't be receiving data at 91.8 FM and 91.6 FM? No. You try it out, you would be still receiving the data, but then again, there would be some element of noise that would be getting introduced. So you would not be getting a pure clear data, but a data that would be having some kind of noise. So for that reason, we say what? Exact tuning to that particular frequency. Now, multiple frequency band can work simultaneously without any time constraint. That is what we are seeing in FM radio. You have 91.7 FM, you have 401.1, 401.0, 92.8 and whatnot. Okay. So basically the radio stations without any, time restrictions, they are utilizing their particular frequency to the fullest. When the user or the receiver wants to receive the data, they are going to tune into that particular frequency and would be receiving the data. So that was what with regard to frequency division multiplexing.
The next topic that we would be discussing would be with regard to the time division multiplexing. But before time division multiplexing, a quick recap of with regard to the points of SDM and FDM. So after having a brief discussion with regard to the spatial division multiplexing, space division multiplexing, we saw that the space has to be allocated for each individual channel. That gives rise to the point that as many number of channels are going to get increased, then that amount of space is required. So this is one of the things that need to be noted under space division multiplexing. And the second thing is that if though there are gaps, there are guard gaps between the spaces, the problem arises when two or more channels are trying to establish themselves within the same city. Now this particular point is talking with regard to an example of a radio station. So what and how exactly the spaces are going to get managed when two radio stations want to broadcast themselves in the same city. So these were the few points that we need to remember when we are talking with regard to space division multiplexing. Next, we had a brief discussion about frequency division multiplexing, how in FDM, in contrary to SDM, now the division that is happening is on the frequency dimension, wherein the channels are utilizing the frequency spectrum throughout the transmission. Okay, so each channel is being allocated a certain range of frequencies. Now this is ideal when we are talking with regard to examples like that of radio stations, wherein the specific radio station can transmit the data throughout the day. The receiver can tune into the frequency and receive that specific data. But when we talk with regard to mobile communication and allocating this kind of frequency, so in that particular scenario, the mobile communication takes place only for few minutes at a time. So that is what is being stated, that unlike your FM radio station transmission, the mobile communication occurs for few amount of time, few minutes. Okay, so if we assign separate frequencies for each possible communication, then there could be what? There could be a serious wastage of frequencies that would be happening, inefficient utilization of the existing frequencies. So this allotment of frequencies to specific channel is in a some way does what? Makes the scheme inflexible in mobile communications, and then it also limits the number of senders. So these are few points that we need to remember when we are talking with regard to space division multiplexing and when we are talking with regard to frequency division multiplexing. Now the next topic is time division multiplexing. So what is time division multiplexing? It is used for a particular amount of time, okay, in which the whole spectrum is used. Now how previously when we had space, so the division was happening with regard to space. When we talked with regard to frequency, the dimension of frequency was taken into consideration, so the frequency was getting divided. In that same way, when we talk with regard to time division multiplexing, now the dimension on which the division is going to happen is with regard to the time domain. Okay, like previous two multiplexing techniques, we have the guard space concept that is getting introduced over here, wherein the two channels who are transmitting should not interfere, and in order to avoid co-channel interference, what is necessary is the guard space. So when we talk with regard to frequency division multiplexing, we had guard spaces to avoid adjacent channel interferences. Here we are trying to avoid co-channel interferences. For that reason, we need to have the guard spaces. Now that guard space is also with regard to the time gaps. Okay, so that is what it is, that guard spaces, now the time gaps have to separate the different periods when the sender use the medium. So it is what? It is the time slot that each channel is going to get in order to transmit their data. One of the important thing is that in order to avoid any kind of interference, it is what? Precise synchronization between different senders is necessary. So synchronization over here would be very essential, not only with regard to the different senders. So this senders needs to have a precise clock timing when a individual channel is going to transmit the data, but the synchronization between sender and receiver is also necessary. So the receiver who wishes to receive the data has to also have a precise synchronization with that of the sender. So this is very essential when we are talking with regard to time division multiplexing. So this two type of synchronization is what is essential when TDM is taking into picture. A simple example that is there in TDM is that of ISDN, Integrated Service for Digital Network Telephonic Services. That how ISDN is getting implemented is through your time division multiplexing. Okay. Another variation with regard to time division multiplexing is that of your clubbing of TDM and FDM. Okay, so you have a technique wherein you club both the techniques, multiplexing techniques, that is frequency division multiplexing and time division multiplexing. So how we were talking with regard to just TDM, here we have frequency and time division that is happening with regard to the respective channels. Okay, and as both the techniques are getting involved, that is FDM and TDM, necessary that guard spaces are needed in both the dimensions. So in order to avoid adjacent channel interferences and in order to avoid co-channel interferences. So in order to avoid these two elements, the guard spaces is needed, and this particular thing is usually used in GSM. So unlike in your FDM, where the frequency slot were getting utilized by one specific sender, in TDM there were issues with regard to synchronization, okay, with regard to precise synchronization between the senders and the synchronization between the sender and the receiver. So when we apply this FDM plus TDM technique that is utilized in GSM, again the Precise synchronization between the senders is essential